right, engineers, so if you guys are here for part 2 for the mechanics of breathing, appreciate it. What we're going to do now is we're going to go over exactly how this actual inspiratory process can produce these changes in these pressures. Okay, so let's go ahead and get started. So where does this all start? Okay, well, let's say that we have here our actual central nervous system. All right, so we have, again, the midbrain, the pons, the medulla, right? So we'll quickly outline that. Again, we're going to have the midbrain here. All right, midbrain. You'll have the pons. You'll have the medulla right here. And then you'll even have right here, which is our spinal cord. So we're taking an actual sagittal section here. So I'm taking a sagittal section, we're looking at it like that. So in other words, I'm taking here and I'm cutting right down. All right? Now, whenever we want to breathe, since this muscle here, you see how we have the ribs? We took a cross section of the ribs here. Connecting between the ribs, you see these muscles right here? These red muscles right there? These ones right here are specifically called the external intercostals. So they're called the external intercostals. Now, the external intercostals are kind of really important muscles for this entire inspiratory process. Okay, they're one of the big ones. But an even really more important one is this big beast right here. You see this big guy right here all the way from one end to the other? This big muscle right here is a very important muscle. This big old beast right here is called the diaphragm. Okay, so this is called the diaphragm. So you have two really important muscles here. External intercostals, which are in between the ribs, and the diaphragm, right, which is going to be right here, right underneath. It's actually what separates the nice thoracic cavity from the abdominal cavity. Okay? Now, whenever we want to be able to contract these, since these are skeletal muscles, we have voluntary control over our skeletal muscles. So let's say from the cerebral cortex, right, from the cerebral cortex, we'll have it coming down from here. You can't see it, but it's coming down from here, right? You could have signals coming down here. You could have signals coming down here and actually stimulating some specific nerves within the spinal cord, right? So let's say, for example, if this is going to be C3, C4, and C5, this would come out, activate these somatic motor neurons, and come and innervate the diaphragm, okay? So this would be C3, C4, C5 nerve root. This is going to be specifically called the phrenic nerve. They actually call this the phrenic nerve, okay? Whereas you have another structure. Let me get Skelly out of the way here. You have another structure here. Let's do this one in, let's actually do this one in this nice color here. Let's say that we keep coming down here though, and we come down to about, we're not going to draw all of them, but there's a couple other ones down in the thoracic region. We'll just do a couple of them. And we'll say for right here, we have from T1 all the way down to about T11. So all the way down. We're not drawing all of them, but for the sake of it, I drew a couple here. From T1 all the way down to about T11, you have these intercostal nerves here. And these guys, these intercostal nerves, are actually going to come and innervate. Let me actually have them coming through here. They're going to be innervating the external intercostals. And when they innervate the external intercostals, they're going to provide a stimulus to the external intercostals. So far, what do we have? Here, I'll put it like here so it looks good. Let's do this like that. Yeah. All right, so we get the phrenic nerve coming here from the C3, C4, C5 nerve roots, innervating the diaphragm. Then we have from T1 all the way down to T11, we're going to have this intercostal nerves, right? So you're going to have your intercostal nerves. And this could be activated by cortical control, right? So we have cortical control there. But you know what else can actually stimulate these also? We're going to talk about it in more detail, but you have a specific set of nuclei located here within the medulla. A special set of nuclei. These nuclei are actually called the ventral respiratory group. And the ventral respiratory group actually has connections, okay, that can actually run here and provide these axons that can stimulate these actual neurons that are going out to supply the external intercostals as well as the diaphragm. So you have an input coming from the cerebral cortex as well as even from what's called the ventral respiratory group within the medulla. Anyway, when these guys are coming out from the phrenic nerve and the internal intercostal nerves, what's happening? Let's first look at how the actual intercostal nerves are working. So we'll work from top to bottom. So the intercostal nerves come over here to the external intercostals, and they cause them to contract. Now, when the actual external intercostal muscles contract, something really, really cool happens. I'm going to show you personally, but then I'm going to bring in an actual anatomy model so we can see it in a better way. So what the external intercostals do is when they contract, they pull the ribs outward. So they pull the ribs like they're coming outward. So you know whenever you have like a bucket with the two handles? So if you have like a bucket with the two handles and you pull the handles actually like this, that's exactly what's happening to the ribs. So one thing that's happening is you're taking the ribs and pulling them outward, which is increasing the thoracic cavity volume. So as you pull the ribs outward, that increases the thoracic cavity volume. Another thing, whenever the actual external intercostals contract, they pull the sternum, they push the sternum out like this. Okay, so when they push the sternum out and upward like this, that increases the thoracic cavity volume anteriorly, a little bit anterior-posterior. Whereas whenever the ribs go outward, that increases it in a horizontal volume, right? Either way, nonetheless, when the external intercostals contract, they pull up. They call it like a bucket handle movement. And then whenever the actual external intercostals contract, they pull the sternum outward, which is kind of like if you guys ever seen like the waterfall, like the old school ones that you do like the pump action there. That's what they call it. They call it like the little water pump action, which is actually pulling the sternum out. Either way, the whole result is increasing the thoracic cavity volume. Okay, so I want to give you guys a better example now. So what I'm going to do is I'm going to bring in an actual skeletal model here so we can get a better idea of what this looks like here, because I want to make sure that this is really, really understandable here. So again, here we're going to have all of these structures. These are our ribs, okay? So all of these are the ribs, okay? The external intercostals actually attach between the ribs. So let's pretend this is actually a rib here, a rib here. The external intercostals would attach here. Now what they do is, the lower part of the rib, where the external intercostals attaches to, it pulls that rib up. So when it pulls the ribs up, look what it actually would do. It would pull the ribs out like this. So you're actually going to pull them outward like this. Okay, so whenever they're contracting, when the external intercostals contract, they pull the ribs outward like this. Now, and also what they do is whenever they're contracting, they kind of push the sternum outward. So two things are happening. The ribs are going outward, and the volume in here is actually increasing. Also, the sternum is coming out farther, and the volume in here is increasing. So that should make sense now, okay? Now let me grab another model real quickly so we can even see a little bit better about these actual muscles here. So let me bring this back in here. So if we see here, we got the skelly. Now what I'm going to do is I'm going to take this actual chest plate here, put it in front of it, okay? So if you guys look here for a second, you're going to notice, again, here's our ribs. But do you see these muscles right here on the edge? These muscles right there are your external intercostals. When they contract, so let's imagine we look at this external intercostal. This point here is actually going to pull that actual rib up. So this is the insertion. This point here is actually fixed, so that's the origin. So when it contracts, it pulls the insertion up towards the origin. And when it does that, again, sternum goes out, which increases the thoracic cavity volume, and the ribs come out like a bucket handle, which is increasing thoracic cavity volume. Okay? So now I'll put these guys back and we'll get back to our actual tutorial here. Okay, so now that we've done that, we should have a good idea what's happening now. So let's actually show that now in a better way here in this diagram now. Okay, so that's the first thing that happened. So the thoracic cavity volume is going to increase. So let's say that that happened. The thoracic cavity volume over here, let's say that it actually increased. So we went out wider, okay? So if that's the case, we would expect the volume in the thoracic cavity to start increasing. Before we do this, before I do this, let me do one more muscle so we can get one more muscle in here. Last one is the diaphragm, okay? What does the diaphragm do? We really need to think about him too, right, before we go over there and show that. So the diaphragm, when he contracts, what actually happens is he actually domes down. So he actually depresses. If he depresses, think about this for a second. Let me actually show you what would look like over here. If this muscle contracted, let's say that its actual muscle contracted, look what would happen to all of this volume here. Look at this. Let's say that it actually went down a little bit. Oh, wow. That's a lot of volume there. So if that sucker went down, what's going to happen to this area now? What happens to this volume? So now the volume is increasing by three ways. One is the diaphragm is actually depressing, increasing thoracic cavity volume. The second one is the external intercostals are pulling the ribs upward, right, and outward, which is pulling them like a bucket handle and pulling the sternum outward. All of those things are doing what? What's the overall result? Increasing thoracic cavity volume. Let's write that down. So what's the first thing that happened? External intercostals and diaphragm contract. And whenever these suckers contract, what happens? By the mechanisms that we mentioned many times already, it increases the thoracic cavity volume. Okay, cool. Well, now, let's see how this affects these many pressures. If I can increase the thoracic cavity volume, let's think for a second. What can happen, because technically this is all connected to the chest wall, right? As the chest wall is expanding and as this is going down, what we would expect to happen here with this whole parietal pleura? Wouldn't we expect it to actually expand a little bit also and to actually go with the actual chest wall? So let's just pretend for a second that I bring this one down. I'm over exaggerating it, but it's going to be, for the purpose of making sense here. So again, what's happening to this parietal pleura? It's getting pulled away, and it would also get pulled away with the chest wall as the chest wall is expanding. As all of this is expanding, what is happening to this actual volume here? Well, the thoracic cavity volume is increasing. So if the volume is increasing, what will happen to the pressure according to Boyle's law? The pressure will decrease. What is the pressure in this area? What is intrapleural pressure? So the intrapleural pressure was originally, what was it originally? It was approximately about -4 millimeters of mercury. That's what it was at rest. So we'll put here on the next to it, rest. But then, during the inspiratory process, the volume actually went even greater than normal because now the actual chest wall is trying to expand. It's pulling that parietal pleura away from the actual visceral pleura. And this whole volume here is increasing, potentially, right? It will actually get even more negative. So the pressure will drop even more. To about what point? The pressure will drop. So let's say that here we show over here what the pressure changes to. The pressure will go from -4 millimeters of mercury to about -6. Okay? So it'll drop down during the inspiratory process to about -6 millimeters of mercury. And this is during inspiration. Okay, sweet deal. Okay, next thing. As this is expanding, look what happens here. Because the thoracic cavity volume is increasing, not only is that allowing for that to happen, but what happens is these lungs want to start expanding too. So because the lungs want to start expanding, something really cool happens. This guy right here, what's going to happen to him? His actual lungs are going to start expanding also. So the visceral pleura is going to start getting closer and closer to the parietal pleura, right? Because again, we have to remember, it is a potential space. But when this parietal pleura is being pulled away by the chest wall, what is it pulling with it? It's pulling with it the visceral pleura. So now what we expect to happen with this lung now. And again, we're going to drag it out here, but as long as we get the point. Look at this. I'm going to bring this sucker all the way down here. What did I just do to the lung? Oh, I increased the actual volume inside of the actual lung. So if I increase the volume inside of the lung, what does that mean for the pressure? That means that the pressure goes down. Oh man, should make so much sense, right? So again, intrapulmonary pressure. What do we say that we denoted that as? We denoted that as P-pole, right? We call that the P-pole. So the P-pole was originally, what do we say? It was about, not negative, it should be 0 millimeters of mercury at rest. But then what happened? What did we say? The visceral pleura was getting pulled with the parietal pleura as the thoracic cavity volume was increasing due to the external intercostals and the diaphragm. So as the volume of this all these alveoli start increasing, what happens to their pressure then? The pressure starts decreasing. So what should it go to then? It should drop down to approximately about -1. So it only drops about 1 or 2. It only drops about 1 or 2 millimeters of mercury. So we're going to put here, let's just put -1. But again, it can drop down about -1 or -2. So it went down 1, so we're going to put -1 millimeters of mercury during inspiration. Oh, it should make so much sense. It does to me somehow. All right, now that we've done that, we should understand how those pressures have changed. But what happens to the atmospheric pressure? Does anything happen with the atmospheric pressure? No, it should stay the same, right? It should stay the same. So the atmospheric pressure should not be affected. Let's write that down though. So the atmospheric pressure, it should not be affected, okay? So it should still be 0 millimeters of mercury if we're comparing it, right? But just for this case, we'll keep it here at 760, just for the heck of it. So we'll say 760 again, millimeters of mercury, and specifically this millimeters of mercury, we could also say as a unit, we could convert it to an atmosphere, right? So 760 millimeters of mercury, which is actually equal to 1 atmosphere. So that's the same. Okay, what about all these other dang pressures now? What about those? Okay, let's get to that second. Let's write down what happened so far. Thoracic cavity volume increased. The third thing that happened, what happened? As the thoracic cavity volume increased, what happened? The intrapulmonary pressure, what happened to his pressure? It decreased. What happened to the intrapleural pressure, the PIP? It decreased. Okay. The last thing to look at is what happens to the transpulmonary pressure, what happens to the actual transthoracic pressure, and if you guys want, we can even say what happens with the transrespiratory pressure. So let's go ahead and see what happens to all of these pressures here. Okay. Well, the transpulmonary pressure we said was what? Let's write it down here real quick. Here was A, B, C. We said that the transpulmonary pressure was the difference from A minus B, which is the intrapulmonary pressure minus the intrapleural. Okay. Well, now it's -1, and this is -6. Let's write that down. So it went from it's -1 millimeter of mercury minus what? 6 millimeter of mercury, right? Minus 6, but actually it should be -6. Should be -6. So -6 millimeters of mercury. So it's -1 millimeter of mercury minus -6. What is that equal to about? Okay, well if we have -6, right, so we're taking -1 plus 6. So what does that equal to? That's equal to +5, right? So it should be +5 millimeters of mercury. So it went up a little bit. But like I said, again, the whole point here is I said, remember it actually went down by -1. It can go down by -1, -2. So if it went down by -2, what would that be? +4 millimeters of mercury. So it doesn't really change significantly, but it can change a little bit in this case. All right, cool. Let's do the next one. The next one we said was the difference between B and C. Okay. Well, the difference between B and C is the difference from the intrapleural pressure and the atmospheric pressure. Oh, we said that this is the transthoracic pressure. Let's write that puppy down. So the transthoracic pressure is equal to the intrapleural pressure, which we said in this case was -6 millimeters of mercury, minus what? 0 millimeters of mercury. And again, what do we say that this should be? The transthoracic pressure should be equal to the intrapleural pressure. And the transthoracic pressure is -6 millimeters of mercury. What does that imply? That's a good thing. That means that the chests are actually recoiling outward. And as the chest wall is recoiling outward, what is it doing? It's pulling on this actual, what? It's pulling on the chest wall, and as it pulls on the chest wall, what happens to the volume in this area? It increases. So that should make sense because this negative is implying that the chest wall is actually recoiling outward. That's good. And again, for the heck of it, we can do this last one here. Let's do this one in red, which is the difference between A to C. And that was the transrespiratory pressure. And the transrespiratory pressure is just going to be the, what? Intrapulmonary, which in this case was -1 millimeter of mercury, right? Minus what? Minus the atmospheric pressure, which in this case is 0 millimeter mercury. And in this case, what does this tell us? The transrespiratory pressure is saying that air is actually flowing in what direction? Well, it was -1 here. So what's our answer here? Our answer is -1 millimeter of mercury. That's the answer. What that means is that air must be flowing from the atmosphere into the alveoli. That's what the -1 millimeter mercury is saying. It's saying that the air is flowing from where? The air must be flowing from the atmosphere into the alveoli. If it was positive, it would be the opposite. It would be flowing out of the actual alveoli and into the atmosphere. Wow, this is so beautiful. All right, so let's write these things down now. Everything that we have here, again, transpulmonary pressure should now be about +5 millimeter mercury. And then the transthoracic pressure should be about -6 millimeter mercury. And then the actual transrespiratory pressure, we said last one was -1 millimeter of mercury. And if we want to reiterate it, the intrapleural pressure actually dropped down to about what? It dropped down to actually -6 millimeter mercury. And then the intrapulmonary pressure, or the intraalveolar pressure, dropped down to about -1 millimeter mercury. Okay, these are all the events that are occurring in inspiration. Now, we have to figure out, okay, all this is good and well, but does our lungs stay like this? No. This is basically doing what? Think about this. What's the pressure inside of the alveoli? What's the pressure inside of there? Okay, it was -1. -1 in comparison to what? -1 in comparison to the atmosphere. So in other words, we could say this is 760, and what is another way that I could write this, guys? 759, right? I could technically write this as 759 if I wanted to. Now, what is that law again? That actual law, Boyle's law. Or not even Boyle's law, just the law of diffusion. The law of diffusion. Things like to move from areas of high pressure to areas of low pressure. So where would the air want to flow? The air would want to flow inwards. And so now, look what happens here. Air starts flowing inward. As the air starts flowing inward and more and more and more into the lung, it'll continue to flow from the atmosphere into the actual lungs until the intrapulmonary pressure at the peak point of inspiration goes until it actually equals the atmospheric pressure. So let me say this one more time here. Let me actually put it over here and pink afterwards to write this over here to make sure that we're clear. Let me explain it one more time before I write it down. This is -1, so it's 759 in here. It's a lower pressure. Out here is higher pressure. Things like to move from high pressure into areas of low pressure. As this air is flowing, it's flowing from areas of high pressure to low pressure. It will continue to flow from the atmosphere into the actual lungs, or the alveoli in this case, until the pressure in the alveoli equals the pressure in the atmosphere. What is the pressure in the atmosphere? 760 millimeters of mercury. So it's going to go until it equals 760 millimeters of mercury. And that is going to be at the peak point of inspiration. So while that happens, when all those events are happening, when our muscles are contracting and all those events, the whole point is to suck air in by pressure gradients. So this will eventually cause the intrapulmonary pressure to equal, if we say it's 760, what does that mean? So what's 760 minus 760? 0. But again, just so that we're clear, again, what would that actually be if we put it in the larger numbers? It would be 760 because it has to reach equilibrium with the atmosphere. So this is what it will be at the peak of inspiration. And then whenever we get ready to go into whenever we get ready to go into expiration, which we'll do in the next video, you'll see how all of these pressures are changing again. So amazing. Okay. All right, guys, so in this video, we talked a lot about the inspiratory processes, specifically with respect to the whole mechanics of breathing. Okay, in the third video, the next video, we're going to see exactly how all of these events are happening again, but in reverse, specifically in expiration. All right, Ninja Nerds, I'll see you soon.